I'm going to explain how to answer this question number 4 using our TGA, which is the compound analyzer. The instrument helps you to know the content of water, the percentage content of water in a hydrate. In this experiment, your goal was to find the percentage composition of water in the hydrate, your unknown hydrate. So the instrument accurately tells you that. So you'll need to compare your accepted value from the instrument with your experimental value. That's going to help you to calculate the percentage error. So how do you analyze your TGA? Remember, you are given an unknown. You're given an unknown, and the unknown will be either of these files, that these charts that I'm gonna put on Moodle. So you find your own unknown and then analyze your TGA. So analyze your TGA graph. So this is how you analyze your TGA graph. So here is a page from your manual. Okay, so I'm gonna again explain to you how to analyze this graph. So usually you just have this shape in the graph, right? This is the mass that was injected into the instrument. That's the mass of this hydrate that was injected into the TGA sample analyzer instrument. Okay, so the graph that was plotted, that's the data that's the graph that was plotted using the data from the instrument. So actually, this is the mass of the hydrate, and it so happens to be this reading right there. So that point is your mass of the hydrate. Please note that that's the mass of your hydrate before you heated it. As you heat the sample, the mass drops. You see the y-axis is mass, so the mass drops. That's why the graph drops down. Okay, and then it reaches a point where you no longer lose any more mass because all the water is gone. So the reading right here is gonna be the mass of anhydrous. That's the mass of the anhydrous salt. Anhydrous meaning dry. It does not have any water because water was lost. So you really want to determine the amount of water lost, and to do that you simply do a subtraction, because you have the mass of the hydrate and you have the mass of the anhydrous. If you do the subtraction, okay, if you find the difference gonna be equal to, difference will be equal to the mass of H2O lost. Okay, why do we need that? Because we need to find the percentage composition of the water. Now remember, this was the original mass. Okay, original mass, that's the mass of the hydrate. This is the final mass after heating the hydrate to a constant mass. So the difference is the mass of water lost. So the thing is, you have to read the mass of the hydrate, which is roughly 25 point, let me just guess, it's 25.25 maybe. Okay, so the original was this, and then it dropped to 25 point roughly 25. Okay, and then if you do the subtraction, I'm just doing a rough illustration here. You should read your graph accurately. 28.629 minus 25 point, actually that's 25.5, because this is 0.2, that's 0.4. Let me say 25.5 roughly. So the difference is gonna be 9, 2, 1, and then 3. that actually is going to be equal to the mass of water lost when you subtract the final mass from the original mass. So to find the percentage is simple. The percentage of water in this hydrate will gonna be equal to the mass of water lost divided by the original mass. All those are in milligrams. The mg will cancel, and then times 100. So let me try and see if this will give me the answer we are looking for. 25.50. Okay, divide by 28.629, and then times 100. So the answer I'm getting here is roughly 10.93%. So you see, that's very close to this number right here. Okay. So for them, their difference, they're ready to be 3.0841, because I know this is not zoomed in. I cannot accurately read that number. So I think it's very close. So that's how you find the percentage of water in your hydrate using the TGA graph. This is actually what we call the accepted value. The accepted value that you need to calculate and fill it in this data table. Where's the data table? Right here. Okay. So the accepted value needs to go right there. Right? This is read from TGA. Okay. You have to calculate it yourself. I'll grade you on that one. The experimental value here comes from your previous table that you must have calculated, which is the average percentage water by mass from your 3 trials. Okay, and then the percentage relative error, this part comes from you using this formula right here in your manual. Percentage relative error is equals to experimental, which is what you got, minus accepted, which is from TGA, over accepted, which is from TGA, times 100. All right, simple to do. Obviously, using your TGA graph, you can read the mass of the hydrate of the salt and the mass of the anhydrous, and then you subtract, you get the mass of water lost. That's what we did here, and that's what you'll need to do here. So to read these numbers, you'll have to do what we call extrapolation. Let me show you. Let's assume this is my TGA. So I would extrapolate the topmost. That mass right there should be exactly that. And then down here, I'll find the bottommost. Use a ruler, please, and read your value right there. That will be the mass of the anhydrous. Okay. After water is lost, this is mass of the hydrate. Subtract those two, you're gonna get the mass of H2O lost. And then using the mass of H2O lost, you can find the percentage of water, okay, which again is what I did here. You just take the difference from the hydrate minus anhydrous, you get the difference. That's the mass of water lost over the original, which you read directly from your graph, times 100, which means the original mass for this graph is right there. Okay, so that's how you work out that question. And then you are asked one more thing in question 4. You are asked what will cause your experimental percentage experimental percentage value of water in your hydrate be higher or lower than what is accepted from your TGA graph. No, it's simple. If your percentage is high, it means you probably weighed wrongly your sample, or you did your math wrongly, so you got a less number of water loss, a higher number of water lost. That's how you get a high percentage. If you have a low percentage, it means most likely you did not heat your sample to dryness, so you ended up with less water than expected, right? Or again, your calculations were wrong. Find more reasons and answer that questions. I hope that helped you out for that question. So again, look for your charts on Moodle to find your unknown TGA graph and use it to answer this problem.